Hi, welcome to Easy Engineering. Today we're going to talk about why we use safety compressed air nozzles, jets, and air knives. In fact, when we're finished, you're going to wonder why people don't use this technology, because it makes a lot of sense to use it. First of all of the technology, whether it's a nozzle, an air amplifier, an air jet, or an air knife, every one of them, all of them use basically make a lot less noise, and I'll explain why in a moment. They're obviously much safer, they use less energy, and they work better. And here's how. The original nozzle was a cone-shaped nozzle, just like this next flow one here. They still are used quite a bit for blow-off and for cooling because they do save a lot of energy, do use a lot of less air. And the way they work is as the air comes out, it entrains the air from the atmosphere, mixes with the air from the compressed air, converts the pressure that's normally lost as noise and pressure drop into flow. Now, what happens that when it does that is you also get laminar flow. Now imagine an open nozzle and open tube. You get a lot of turbulence. A lot of noise, a lot of wasted energy, and it's not very effective at a distance. The laminar flow that's maintained with this kind of a nozzle makes it work much better at a distance. So you get less noise, improved safety, you use less energy, and they work better because of the laminar flow. Today now, we have much more engineered nozzles as well, which give you a higher force per CFM. So when force is very important, this type of engineered nozzle, this is an air mag nozzle from Next Flow, gives you a higher force per CFM. So again, nozzles have developed over the years, and you get a much better force per CFM ratio. You still get the safety, you get less noise, you use less energy, and with the laminar flow, works better. Now, that's the nozzle. When you make this air amplifying nozzle larger, you get an air jet. Make it larger still, you get an air amplifier like this. The nice thing about air amplification technology is that the bigger you make it, the more efficient it becomes in converting pressure to flow. So, when you go to an air jet or an air amplifier, you get even less noise produced, you get even less energy that's used, and not only that, you get a larger footprint. So instead of using a bunch of nozzles to blow something off, you use one amplifier to blow off a larger area. Again, less energy, less noise, much better efficiency, and better job overall. So that's an air amplifier. You can also make them flat. This is a flat jet. This is like a small air knife. What's nice about this, you get, again, a high force per CFM coming out of it. Now, when you go to an air knife, what's nice about an air knife is basically a long length of the nozzle. So you can make them small, you can make them short, you can make them much larger. The original air knife is like this one, where the air comes out of the air knife, bends 90 degrees, and trains air from the atmosphere, and you get amplified airflow. Very effective, great deal of noise reduction, a lot of energy reduction, and again, intrinsically safe. The newer air knives, which are much more popular now, like this extreme air blade air knife from Next Flow, is where the air comes out straight. Here you get a higher force per CFM. So these are a lot more energy efficient, even more quiet, and of course are very popular as a result because of increased energy and the lower noise levels. So when you look at what you can do with air amplification, when you look at what you can do with safety air nozzles, jets, and air knives, why would you not use them? So next time, we'll talk about another product at Easy Engineering.